Hello students, now today we will discuss the classification of discrete time signals. So previous class we have already discussed what is the basic signals which have been placed great important role in signal processing and communication systems. The basic signals are your impulse sequence, unit sample sequence, ramp sequence, sinusoidal sequence. These are the basic signals. Already I told you what is impulse sequence. An impulse sequence exists at n equal to 0. So at n equal to 0, in impulse sequence at n equal to 0, this is nothing but your del of n. This is your n. At n equal to 0, del of n equal to 1, del of n equal to 1 for n equal to 0 and 0 elsewhere. This is your impulse sequence or unit sample sequence. Then I told you what is the properties of impulse sequence. An impulse sequence or unit sample sequence, the properties are what? That is your del of n is nothing but what? U of n minus u of n minus 1. So another property is your any function if n equal to minus infinite to infinite f of n into del of n minus n naught. What does it mean? And this is your shifted impulse sequence. If the shifted impulse sequence multiplied with any function, and condition is that function must be lies in between this limit, then we will put these values what? Del of n minus n naught means n minus n naught equal to 0 or n equal to n naught. So in place of n we will put n naught. The value will be your what? Now f of, in place of n we will put n naught. So these are the two vital important properties of impulse sequence. In discrete time signal, so any type of discrete signal we can be represented in terms of impulse sequence. It is very, very important. Then already I told you what is unit sample sequence. In unit sample sequence is what? So in unit sample sequence for n greater than or equal to 0, u of n, that is 1. That means here 0, 1, 2, 3, 4 dot dot. This is your n and this is nothing but your u of n. So what is its properties? So u of n equal to 1, u of n equal to 1 for n greater than or equal to 0 and 0 elsewhere in case of unit sample sequence. So these are the two important properties, basic signals, that is your impulse sequence and unit step sequence. So another function already I told you, that is your ramp sequence, that is your r of n equal to n. So what does it mean? R of n equal to n if x axis is your, that is your n equal to 0, 1, 2, 3 like this. At for n equal to, this is nothing but your r of n. For n equal to 0, n equal to 0, r of 0 equal to 0. For n equal to 1, and this is 1. And for n equal to 2, r of 2 equal to 2. So this is your 2. N equal to 3 and this is also 3. So this is nothing but your ramp sequence. This is your ramp sequence. Ramp sequence. So already I told you in the previous class how you represent the signal, and then there are some elementary basic type of signals, that is your unit sample sequence or unit impulse sequence, and also ramp sequence, and also exponential sequence and sinusoidal sequence. Then now today we'll discuss, that is your classification of discrete time signals. So as far as classification of discrete time signals is concerned, so we will now follow that is your energy and power signal. This is very, very important as far as signal system and digital signal processing is concerned. What is energy signal and what is power signal? So energy signal, what do you mean by energy? Energy signal. Energy signal. The discrete time signal, the discrete time signal the energy E of discrete time signal x of n can be defined as the energy E of a discrete time signal x of n can be defined as, that is your sigma n equal to minus infinite to infinite x of n square. It is very important as far as the discrete time signal is concerned. In communication system, in continuous time signal E equal to x of t square. So that is your as far as energy is concerned, so energy E of a discrete time signal x of n can be defined as E equal to n equal to minus infinite to infinite x of n square. Here n is the for any discrete values of n. So what is power signal? If we will categorically define between energy and power, so power signal, the power P of discrete time signal x of n, the average power P of discrete signal x of n can be defined as what? The average power P of discrete time signal x of n can be defined as P equal to limit n tends to infinite 1 by 2n plus 1 summation here n equal to minus n to n x of n raw square. It is very important. You have to memorize these two formula, energy and power. So this is your energy signal, and the limit is your minus infinite to infinite. If we calculate the average power P of a discrete signal x of n, we can be expressed as the average power, that your limit n tends to infinite 1 by 2n plus 1 x of n square. N is the some period of discrete signals. So P equal to limit n tends to infinite 1 by 2n plus 1 x of n square. If we define the energy certain period, certain that is your if we will define average energy, that means that is your for n greater than equal to minus n to less than n, there is some interval, that is your minus n to n, that is your the E can be written as what? That is your sigma n equal to minus n to n, that is your x of n square. And here this equation is for what? That is your limit is minus infinite to infinite, but here if the period is your minus n to n, in place of this limit I can put n equal to minus n to n x of n square. Suppose I can be written denoted as E suffix n. Suppose this is your let equation number 3. What I am trying to say is what? So energy E, therefore equation 1 can be written as here E equal to limit n tends to infinite, that is your En. Is not it? Here E, the value the average energy E of a discrete signal of x of n can be defined as n equal to minus infinite to infinite x of n square. Here energy, if we'll consider the interval that is your minus n to n, in place of minus infinite to infinite I can put n equal to minus n to n x of n square. So here this can be written as in terms of this, I can write this expression in terms of this equal to limit n tends to infinite E of n. So here E equal to limit n tends to infinite E of n, then I can be again the equation 2 can be written as what? That is your in place of this limit n tends to infinite x of n square, in place of this the power can be written as, therefore the equation can also be defined as what? P equal to limit n tends to infinite 1 by 2n plus 1. Here in place of this n minus n to n x of n square, in place of this I can write En. So what I am trying to say is what? This power and this is your energy. This relation is holds for what? The relation between energy and power. Here energy formula, as far as the E equal to what? A discrete time signal x of n can be the energy of discrete time signal x of n can be defined as n equal to minus infinite to infinite x of n square, and average power of discrete signal x of n can be defined as, that is your limit n tend to infinite 1 by 2n plus 1 x of n square. The limiting value is your minus n to n. If we will consider the energy for a certain period n greater than equal to minus n ln, then the limit can be changed here n equal to minus n to n x of n square. So what I am trying to say, energy and power, there is a relationship between energy and power. Here P can be also written as limit n to infinite 1 by 2n plus 1. In place of this you can put average energy En. From this expression what we conclude, if suppose energy is finite, that is your what? If n tends to infinite and this value is what? If energy is finite, then we will calculate whether the power is 0 or not. If energy is finite, then the power becomes 0. The signal is called the energy signal. It is very, very important. If energy is finite, important thing is what? Energy and power. If energy is finite, and power becomes 0, power becomes 0 means what? If it goes to the previous slide, here some finite by infinite n tends to infinite, some finite by infinite, and the value power becomes 0. If energy is finite and if n tends to infinite, something by infinite, that becomes 0, and the signal is called the energy signal. See, most of the competitive examination or you will found there is a relationship between energy and the question has been asked to find out whether the signal is energy or power. If energy is finite, the power becomes 0. The signal is called the energy signal. Are you getting or not? If energy is finite, if n tends to infinite, that is your what? The denominator is infinite, finite by infinite, the result is 0. That means power is 0. If energy is finite, the power is 0. The signal is called the energy signal. Another thing is, if energy is infinite, suppose we will calculate of a discrete time signal x of n, means what? If we will calculate energy of a discrete signal x of n and we will find the energy is infinite. Suppose if energy is infinite and n tends to infinite, infinite by infinite, not determined. If energy is infinite, that may be what? The power may be finite or infinite. Remember, if energy is infinite, the power infinite by infinite is not determined, then we will follow L'Hospital rule or any other procedures how to calculate and put the limit and evaluate the value of power. If energy is infinite, then infinite by infinite is not determined, then we will follow certain rules. If energy is infinite, the power may be infinite or finite. If energy is infinite, the power is 0, the signal is called the energy signal. If energy is infinite, the power is infinite, the signal is neither energy nor power. If energy is infinite, the power if energy is infinite and the power becomes 0, we can say if energy is finite, the power becomes 0, the signal is called the energy signal. If the power is infinite, power is finite, if the power is finite, we can say that it is a power signal. Again, if energy is finite, the power becomes 0, the signal is called the energy signal. If energy is infinite, the power is infinite, the signal is called the neither energy nor power. If energy is infinite and the power is finite, the signal is called the power signal. So there are three conclusions. But one conclusion is what? If energy is finite, the power becomes 0, the signal is called is called energy signal. The signal is called energy signal. Energy signal. Okay. If energy is finite and power becomes 0, the signal is called the energy signal. Number 1. If energy is infinite, if energy is infinite, if energy is infinite, the power may finite or infinite, may finite or infinite. If energy is finite, the power may finite or infinite. If power is finite, then it is called as power signal. Power signal. If energy is infinite, the power may finite or infinite. If the power is finite, then it is called the power signal. And if power is infinite, then it is called as neither energy or power signal, neither energy nor power signal. Neither energy nor power signal. There are 3 cases. First case 1, whether it is energy signal. Second case, whether it is power signal. Third case, whether neither energy nor power signal. So 3 conclusions we have derived from the previous expression. 3 conclusions we have derived from the previous expression, that is between energy and power. If energy is finite, the power becomes 0, then the signal is called the energy signal. If energy is infinite, the power is infinite, the signal is called neither energy nor power. If the energy is infinite and the power is finite, the signal is called the power signal. So we have derived three conclusions. So here we have to determine whether the discrete signal x of n is either energy signal or power signal or neither energy nor power signal. So now let us we will now discuss examples. From examples we will derive or we will discuss for a discrete signal x of n how the signal is either energy signal or power signal or neither energy nor power signals. For example, determine the following discrete time signal, whether it is energy, power or neither energy or power signal. Okay. So now the question is given, x of n equal to 1 by 3 to the power n u of n. Now we are going to calculate the discrete signal. We have to evaluate whether the discrete signal is either energy signal or power signal or neither energy nor power signal. Solution. So x of n equal to 1 by 3 to the power n u of n. First of all, we have to determine energy signal. So energy E of discrete signal x of n can be defined as E of n equal to minus infinite to infinite, that is your x of n square. Here u of n means what? Unit step sequence. If any sequence multiplied with u of n, you have to know that u of n means what? U of n equal to u of n equal to 1 for n greater than equal to 0. So any positive value of n, that function will exist. So that means in place of this limit n equal to minus infinite to infinite, the limit is from what? 0 to infinite. In place of n equal to minus infinite to infinite, so the limiting value can be changed, that is your n equal to 0 to infinite, because of this u of n. U of n is nothing but is your what? Unit step sequence, and unit step sequence is nothing but u of n equal to 1 for n greater than equal to 0. For any positive value of n, the u of n value is 1. So 1 is multiplied with any function, the value will be 1. So that's why this u of n, if the u of n is multiplied with this, so you have to sure that the limiting value is from n equal to 0 to infinite. Then x of n, in place of x of n, you will put what? 1 by 3 to the power n square. Are you getting or not? So that is what? And u of n is 1. And this value can be written as what? Sigma n equal to 0 to infinite, that is your 1 by 3 square. That is your what? I can write 1 by 9 to the power n. Okay. 9 I can write 3 square, that is 9, 1 to the power here n, that is your what? 1 by 9 to the power n. And that is a formula. As you know, sigma n equal to 0 to infinite, suppose I can write a to the power n, and n equal to 0, this value is what? 1, first value. For n equal to 1, the second value will be how much? Summation means addition, add. N equal to 1, that is your a. N equal to 2, a square. N equal to 3, a cube, plus dot dot. And the series is nothing but what? 1 by 1 minus a. So that's what, if n equal to 0 to infinite, 1 by 9 to the power n, and this value will be now how much? That is your 1 by, here a is nothing but what? A is nothing but 1 by 9. A is nothing but 1 by 9. So here I can write 1 by 1 minus a. A is nothing but 1 by 9. And this value is what? 1 by 9 minus 1 by 9. And this is nothing but what? That is your 9 by 8. Here energy of discrete signal x of n can be written, we will find the value of energy of discrete signal x of n is your 9 by 8, and you can write here it is an finite value. It is your finite value. From this example, so energy is, since energy is finite and the power definitely 0, because if we have already derived this expression, if energy is finite and power becomes what? If n tends to infinite and this is something by infinite equal to 0, the power will be 0. And so here power p of discrete signal x of n can be defined as, that is your limit n tends to infinite 1 by 2n plus 1 summation n equal to minus n to n, that is your x of n square. And this value is nothing but limit n tends to infinite, this is some finite value, and n tends to infinite and some 9 by 8 by infinite, and the value will be how much? Some finite by infinite, some finite by here infinite, and the value becomes 0, and the signal is called what? That is your what? That is equal to 0. Okay. So if energy is finite and the power becomes 0, the signal is called the power signal. So this is one of the example. If the question has been asked to find out the x of n equal to 1 by 3 to the power n u of n, whether the signal is energy or power signal. So next example, if we move to another example, that is your, suppose find whether the signal is, find whether the given discrete signal, discrete time signal is energy or power or neither energy nor power, neither energy nor power, and the question is given x of n equal to, suppose e to the power j pi by 2n plus pi by 4. If in this example we have to determine whether the discrete signal is, whether it is energy signal or power signal or neither energy nor power. So how will you evaluate whether the signal is energy or power signal? We will start from the using the formula energy. The energy E of discrete signal x of n can be defined as, there is a formula, n equal to minus infinite to infinite, that is your x of n mod square. In place of x of n, we will put what? That is your n equal to minus infinite to infinite x of n. The value of x of n is what? E to the power j pi by 2n plus pi by 4 square. The value is how much here? So as you know that, so there is an, so e to the power j omega plus theta mod, the value is how much? E to the power j theta, that is your cos theta plus j sin theta. If you will get the absolute value, cos square plus sin square value will be 1. So e to the power j something, the value will be 1. The value will be 1 here. And this mod value, the absolute value of this discrete signal x of n, it can be, the value is how much? The value will be 1. So that's what sigma n equal to minus infinite to infinite, and this is 1. What does it mean? So the energy is finite or infinite. If we will count 1 plus 1 plus 1 plus infinite times, the value will be how much? The value will be infinite. Here energy comes infinite. Then we will move what? Whether the signal is either a power signal or not. Using this formula, power signal, power. The power P of discrete signal x of n can be defined as what? Limit n tends to infinite 1 by 2n plus 1 sigma n equal to minus n to n x of n square. And the value is how much here? Limit n tends to infinite 1 by 2n plus 1, and here sigma n equal to minus n to n. N equal to minus n to n, the value of xn is nothing but 1 here. So what is this value? What is this value? N equal to minus n to n 1. That means for n equal to minus n, that is 1. N equal to minus n plus 1, that is 1. 1 plus 1, 1. The interval is your minus n to n, that is your 2n. So if we add this one, 1, the value is how much? This value is nothing but 2n plus 1. For example, if I will say n equal to minus 2 to 2, that is your 1. But in n equal to minus 2, that is 1. Plus, again minus, after minus 2, that will be what? Minus 1. N equal to minus 1, that is 1, plus 1. Then after minus 1, that is 0. Then 1. Then 1, that is 1. Then 1, that is 1. Then 2, that is 1. So total 1, 2, 3, 4, 5. If n equal to minus 2 to 2, if we add this interval 1, the value will be how much? That is your 5. Because if n equal to minus 2 to 2, and the series will means what? For n equal to minus 2, the value is 1. Then after n equal to minus 2, then minus 1. And n equal to minus 1, again 1, summation means plus, again plus, n equal to 0, the value is 1, n equal to 1, the value is 1, n equal to 2, the value is 1. So that means how many number of ones we have added here? 5. 1, 2, 3, 4, 5. Similarly, n equal to minus n to n. Here 2 plus 2, 4, plus 1, that is 5. Here n plus n, 2n plus 1, that is 2n plus 1. So in place of this, so I can write limit n tends to infinite, that is your 1 by 2n plus 1, and here it is nothing but what? 2n plus 1. So that means what? This value is how much? This value is 1. This value is 1. So the power becomes what? That is your, if n tends to infinite, if n tends to infinite, this is your infinite, this is your infinite, infinite by infinite. So infinite by infinite means not determined. So that means again we will apply some rules, and the value will becomes what? This is nothing but what? If we will cancel out, this value is nothing but 1. Here 2n plus 1, 2n plus 1, that will be cancelled out and the value will be 1. Here energy is infinite and the power is finite. The signal is what? The signal is power signal. So from this conclusion, so since the energy is infinite, since the energy is infinite, energy is infinite and the power is finite, then it is a power signal. Okay. So from today's class we have already discussed the classification of discrete time signals. In classification of discrete time signals, first of all we have discussed what is energy and what is power. In energy signal, the energy E of a discrete signal x of n can be defined as n equal to minus infinite to infinite, that is your x of n square. X of n is a discrete signals. Similarly, the power P of a discrete signal x of n can be defined as limit n tend to infinite, that is your, the power P of a discrete signal x of n can be defined as P equal to limit n tend to infinite 1 by 2n plus 1 in the interval n equal to minus n to n x of n square. So if we will relate the energy and power, there is a relation between energy and power, P equal to limit n tend to infinite 1 by 2n plus 1 into En. So that means from this relation we have derived, if the energy is finite, the power becomes 0, the signal is called the energy signal. In second case, if energy is infinite by infinite is not determined, then we will move to what? We have to check by infinite is a indeterminate forms, then we will move to move certain procedures and to evaluate whether the power becomes finite or infinite. If the energy is infinite and the power is finite, then we can say this is a power signal. If energy is infinite and the power becomes infinite, then you can say that it is neither energy nor power signal. With the help of these following examples, we have used these examples. X of n equal to 1 by 3 to the power n u of n. Since u of n is multiplied a sequence, the sequence is from n equal to 0 to infinite. Because u of n is multiplied this, it indicates that u of n is a n greater than equal to 0, u of n is 1. So that's why the limit changed to 0 to infinite, and we have, using this formula, we have find u of n equal to, that is your 9 by 8, some finite value. And if energy is finite, something finite by infinite, that will be 0 and the power is 0, the signal is called the energy signal. In this example we conclude that energy is finite, the power is becomes 0, the signal is called the energy signal. In the second example, x of n equal to e to the power j pi by 2n plus pi by 4, x of n is a discrete signal is given, and we have evaluated whether the signal is energy or power. Energy E, we found energy is infinite, and energy is infinite, then we will proceed whether it is power becomes finite or not by using this formula, and we have find the power is finite. Here in this example energy is infinite and the power is finite, the signal is called the power signal. So now I will stop today. The next class we will proceed another type of signals, that is your even signal, odd signal, periodic signal, aperiodic signal. There are so many different types of signals. We will proceed. Thank you.